First of all, any questions about anything before we begin? The normal questions that will be answered. Yes, you're going to have quiz next day. It's going to be on inheritance. I'm going to give you a class, and I'm going to ask you to inherit it into a new class with features. So I'll tell you the details of the thing. So that's going to be your quiz for the next day. And every time, every lab that you're coming to class, there's going to be a quiz, and it's going to be a programming quiz. Okay? I may add a few concept thingies in it, but it's going to be, you're going to at least have one coding in it. Okay? That's that. One thing that I noticed marking your midterms is that you don't read, as I mentioned at the beginning of the semester. You don't read the questions and you start answering. You think you know the answer. Don't do that. Read the question. Many of you did parts that you were not supposed to at all. You wasted your time writing very good code that has nothing to do with what I had to mark. Okay? See what the question is, answer the question. Leave those things for your project. And warning to those people who are copying the project from friends this semester and friends last semester. I'm warning you. Careful. Okay? That's that. Any questions before we begin? No questions? All right. So our friend with the microphone is going to tell us what are the 3 pillars of object orientation, 3 things that an object-oriented program relies on. What are those 3 things?
One of them is inheritance.
And the other one is?
Polymorphism.
And the other one is? Inheritance, polymorphism, and the most important one, actually what we begin. They actually said it reversed. It has to be the other way. So encapsulation, that's right. Packaging, encapsulation, that's perfectly good. You can give it to the gentleman in front of you. He's closer. All right. So these are the 3 pillars. Now to this point, we have done encapsulation. And the encapsulation was to
hide the
information hiding. That's right. Pass it. Information hiding. That's right. Information hiding, which means it is, what is information hiding? Encapsulation is information hiding. What does it mean?
Outside of the object doesn't touch the private method or attribution.
Which means? He's saying it like information hiding, don't touch the what? Don't touch the class inside, which means? Sorry, I do this. This is really like, this makes people subconsciously to think. This action of trying to get you to talk and not only listen forces you to think. Even you are not the person who's answering, but everybody's answering in their brains. So you remember, you can say pass and goes to the next person. Okay, just letting you know. Okay, so information hiding, don't touch the class. What was encapsulation? That's what we are saying.
It's not like make a motorcycle out of bike.
No, that's inheritance. That's inheritance. So what is encapsulation?
leave the important thing and then abstract.
Everybody's saying all the features that I always teach in class. Take the important things and leave the unimportant. That's abstraction. That's not encapsulation. Abstraction is what we do in any programming thing. It has nothing to do with object orientation. You have to do abstraction to be able to write a program. To get the parts that is important for you, ignore the parts that are not. Encapsulation was information hiding, don't touch the class, inheritance, abstraction, and?
Encapsulation is more like hiding and protecting, and then just accessing.
Hiding and protecting, which means it is? Seriously, not of what, like if you were at an interview, I wouldn't have hired you now. Even though you know what the answer is, but you cannot just speak the answer. It's your turn. No, you know the answer. Encapsulation is?
Only allow access on like what data you want to show outside. Like
Yeah, but it means
Packaging everything together into public and private.
thank you. No, okay, all of you are being students, which means you're actually telling how you're coding. That's not, you simply, when I say encapsulation, you simply say put data and behavior together. And all the other ones are the little things that you put beside the dish. You know what I mean? That's the main course. The main course is that encapsulation. What is a capsule that you eat? They put the stuff inside a capsule and you know? Capsule is anything that you put the things together. Encapsulation is that. You encapsulate things, you put the things together. And that causes information hiding because it's inside the capsule. You don't see it. That means don't touch the class, which means you only take the parts that you want. And inheritance I'm going to teach today, and abstraction we are doing it every day. Are we okay down to this point? Okay, so we know encapsulation. So we have done encapsulation. We have created the classes. And the classes we created, they have data in it, and they have methods in it, okay? Data that we put inside the class, we call them attributes. So in object orientation, they are called attributes. In C++, they are called member variables. The methods, the actions we put in a class, we call them methods in object orientation. In C++, they are called member functions, right? Member functions. And these are the things that we have. We have special functions, special actions that we do inside the class that they are not functions, and they are
constructors.
Constructors and?
Repeat the question.
Okay, so he was actually answering the second, says, and then I stopped him. So we said we have methods that are actually inside the class that do something, and then we have other actions that we call it special instruction in special functions. Those special functions are called constructors and destructor. Thank you very much. So constructor and destructor was the thing. So this was encapsulation, putting the data and behavior together. Then we learned, we know polymorphism. When we're talking about polymorphism, we said polymorphism is, let him find it.
Other ways?
Other ways. So polymorphism means other ways of what?
Doing the same thing in many different ways.
Doing the same thing. That he did the interview answer. Like if you want, like you go to an interview and somebody wants to ask you what is polymorphism, doing the same thing in different ways. Always remember, doing the same thing in different ways. So that was the polymorphism. So we know what polymorphism is, and polymorphism, one of the very first thing that we learned polymorphism was what? What do we do that makes things polymorphic down to this point? We can do four different categories of polymorphism we have. Okay, remember, 4 different categories of polymorphism. 2 of them we know now. Okay, we know that they exist. Okay, I haven't categorized it yet, but you'll know it. Okay. So one of them is what? What do we do that makes things polymorphic? Do you remember?
Function overload.
Function overload. Function overload is what we do in C++. When we do function overload, functions are different in what? And they become overload. Do you remember?
Pass.
Gentleman with the cool flask? Okay.
The function overload, was it when you pass the, or you go past the limit of bits that the,
oh, you're being philosophical to me. No, that's not. Very easy. It's very easy. What is a function overload? Quick.
Having different functions with different parameters.
Thank you. That's it. Functions with the same name, the exact same thing as polymorph. Polymorphism doing the same thing in a different way. With overloading, you have the same function with different number of arguments. We're good with this? Now you'll be my hero, my lady, if you tell me what is the other one. I don't think you can answer it. It's a difficult question. So we know one thing we advertised as polymorphism, and that was function overloading. There is another thing that is polymorphic that is actually in C. It has nothing to do with C++. What is that?
I'm not sure. Is it reference?
No, no, references. References are in C++. We don't have references in C. Do you remember? Anybody knows, other than function overloading, what do we do that is polymorphic, that you are doing the same thing and different things happens automatically?
Is it shadowing?
Actually, very nice choice of thing. But shadowing is not that. Shadowing is something that you'll see. It's going to come later. But it's not shadowing. No, it's not. But very, very close, though. Very close. In C, you did it. And she's absolutely right. We do shadowing in C. But what is it? Anyone? In C language, what things you do and automatically different types are involved without you changing anything? No, we do have dynamic memory allocation in C, but you have no idea how it's done. It's very difficult, actually. In C++, it's like that. In C, it's crazy. Casting, thank you very much. You got 1% for final. Okay, so did you ever get 1% before? Did you ever get a percentage? Bonus mark? Yeah, this is the first one. You got for midterm already? Oh, you already got, so you're not getting it. Okay, so I have to give it to another person. Who else said casting? So casting it is. Casting, actually I'll give you a 1%, that was a bad thing. Casting is the one. So you create a function that receives a float, but you put an integer and it works. How does it work? It temporarily casts that float integer to a float, and the function float gets it, and yada, yada, yada. So it is polymorphic, but we don't just realize. It's just they told us it's casting, and that's essentially what it is. Are we good down to this point? Who has the microphone? Actually, you have it. Yeah, so we learned all those things. Now we want to learn how do we do inheritance. It goes pretty quick, so you have to pay attention. So although I put it so the class ends exactly at 12:20, I said? 12:20. I'm going to bing it at 12:20 so I can pack up before the gentleman comes in. The concept is so tight, and it has kind of a cascade thing. So we'll go very quick. And suddenly you're going to see 3 weeks material is covered in an hour and a half. OK? So pay attention. But because everything goes back to back very nicely, you will understand it perfectly. OK? First, we have to understand what inheritance is. We talked about it at the beginning of the semester, but I'm not going to, I'll do it in a way that we did not, because at the beginning of the semester, everybody's new in a class, and you're thinking, like, how many things I want. And, you're looking, this nice ceiling over there. Look at the projector, and while I'm talking about inheritance. But now I want your attention, OK? So we said inheritance is to have a design. OK? You design something. How do you design something? You think about encapsulation. You think about polymorphism. You put the things together. You do abstraction. You're going to say, I want to have an employee. So you want to have an employee. What does it? You think about all these things. What an employee has. I'm going to say employee number. So what is important for me? What is this employee thingy I'm creating? So I'm going to say, because I want to pay them salary. So you're going to say, oh, OK. So if you wanted to calculate the salary, I'm going to say yes. So I'm going to say, OK, first of all, I need to know what is the name of the employee. So that becomes an attribute. I need an employee number. That becomes an attribute. OK, and I want to know how much the employee is paid. Then you're going to say, how is it paid? I'm going to say I have two different ways. I either pay salary or it's hourly. So I'm going to say, so I have two different ways. So I'm going to create a flag. I'm going to create a Boolean and call it salary. So if it's salary, I know it's yearly. If it's not, I have to calculate. So you put all these stuff inside an employee, and you create a constructor. The constructor accepts the name and the employee number, so the employee is created, and then you create something like a setter program, a setter function to set the hourly rate, for example, because hourly rate may change, name and employee number doesn't change. That's why it's in a constructor. But employees' hourly pay may change, and number of hours that it works, the employee works, or they don't work at all because it's salary. So you think about all these things. I'm telling you to understand that first you design something. So you design this employee, now employee is working, life is beautiful. Then you are designing this employee in Seneca, right? And somebody's telling you, I want you to create a class for a teacher or a professor. What would you do? Start from the beginning, name, employee number? No. You're going to say, professor is an employee who teaches something. So you get the employee with all the bells and whistles that you designed before. You don't touch it again. You're going to say, teacher is an employee with a subject or profession or category of things that he can teach, things like that. You just add more features to an already existing design without changing the original design. Remember, when you are doing inheritance, you are fiddling with the design. It has nothing to do with the objects that you are creating. So when you create an instance of employee called E or EMP, that's an object. That's not being inherited. This is why one of the worst examples of inheritance is to say, me and my father, we are inherited. I inherit everything from my father. That's not the case. My father and I are both instances of the male human being class. And I explained to you exactly between me and my mother. My mother and I are from two different classes, female human, male human, and they are both inherited from original human. So we have a human object. Out of human object, we have male and female, and my mother has a function called birth that returns a human that happens to be male. So it's not inheritance. Inheritance happens in design. Human, male, female, things like that. The instance that is me, you, they have nothing to do with inheritance. We are just objects. Do we understand this? Okay, so this is what inheritance is, and I'm going to give you a series of examples I have written 20 years ago, and it just worked. So I'll bring them in one by one. I'm going to show it to you. We'll go through it, and we'll understand what inheritance syntax is now that we know what it does. Questions? Suggestions? Objections? Okay. A pause. So we just know this. Teaching you how to do AI. I remember that I need to do that because people keep asking me, how do I use AI? Not to cheat and learn from it. Okay, have a conversation with AI as if, sorry, this is a pause. Let's say I want those information to sink in. I'll bring up the examples. But before doing that, I just want to show you this. So what do we go with AI? Let's go DeepSeek. Is that good enough? DeepSeek, I think it is, right? DeepSeek AI? DeepSeek, there you go. No, that's not DeepSeek. This is DeepSeek? No. There you go. This is DeepSeek. This is DeepSeek. There you go. DeepSeek, DeepSeek. Start now. Log in with Google. That's me. Continue. Okay, so create a brief lecture with simple examples for inheritance in C++. if there, oh, you don't need that, never mind. There you go. So you go through it, you read that. It's going to give you examples, little things. It goes, what is, and it talks, and if you see, it's say multiple inheritance, this and that, and it shows you stuff like that. You see, it actually showing, funny thing is actually almost using the same thing that I'm using. Probably it got my code from somewhere. I'm serious. See, so this is actually what I write for my lectures. Okay, so, and it's going through, as you see, it's actually giving you all the stuff that, holy crap, it's actually thinking in my code. But it's interesting. So it goes through all these things. So you read it, and you read the first part that you don't understand. You go over there, and you simply put questions on that. Like, at this topic, you mentioned this. I didn't understand. Explain this part more with some code. After it's done, you simply say, give me a very simple question to code and answer without answering, and later check my answer. It's going to give you a very simple thing. Write it, test it, give it to it, and see if it answers you, if your answer is correct or not. And do like this. And when you do the first one, say, now make it a little bit more challenging. And then do like that. Keep going like that. And that's going to, then you're going to use AI to actually learn. If you say, my professor told me the quiz is like this. Can you give me an example for the, and memorize that. Then you bring it to the quiz. You dump that thing that you got from there into my quiz. And you see at the top, I'm going to say irrelevant answer. And you get 0. Don't do that. Do it like this. OK? You do this. Believe me, if I had this thing when I was studying computers, oh, like I remember how I learned C language. You have no idea, like 2 weeks, I was going into streets to find a book, and I found this crappy book, Turbo C++, Turbo C language. I cannot even tell you, like it's the pain that we went through to be able to find knowledge to learn. It's at your fingertips. Please use it properly and become genius as you can, okay? If you use AI to do your work for you, you're going to be dumb as a doorknob. What is that thing that it says? Don't give me fish, teach me how to fish. That's what you need to do, and I'm not joking. So, ta-da. Okay, that was a brief thing before teaching what inheritance is. And because everybody keeps telling me, and obviously it happens 4 weeks before the semester ends. Nobody does that at the beginning. I say, if you need help, come to me at the beginning. Nobody does that. Anyways. Remember at the beginning of the semester I told you, please come at the beginning of the semester you have problem? Not a single person. Anyways. We're good? Now for your OOP244NAA. If you have me as a teacher, God bless you. No, I mean, you may rest in peace. But if you have someone else, whoever you have, right at the beginning of the semester, and this is for all your OOP244NAA. When the semester ends, put the OOP244 and eat it and digest it 50 times before you come to 345. Okay? Because in 345, we're going to tell you advanced stuff in C++. And when I'm going to teach you how to do parallel processing, which means running 50 programs parallel at the same time and communicating with each other, you're going to think, is that a constructor? Please, remember that. All right. Did I scare you enough? Are we good? Yeah. All right. Good job. OK, so now, what was inheritance?
What anti-stress drug you suggest?
What is inheritance?
Inheritance is when you have an object and you have to add some feature to it.
Beautiful. Take that object, put it, and it's not object, it's class.
I'm sorry. It's class.
Object you never inherit. Objects cannot get inherited. Classes can. Remember, design can be inherited, not objects. So thank you for that thing. Because I just wanted to bring you, as soon as I change the topic and I go back to original, you switch back to your previous knowledge. Remember what I told you, design. So, long time ago, in a galaxy far, far away, I created this thingy. So I'm going to add to the solution. So let's first do over here. In here, I don't know if I'm going to use this or not. Add new item. I don't know if I'm going to use the lecture part much. If I need to, I'm going to come back here and teach you, use it. But I'm going to use several projects in this solution. So this essentially is, this is the first time that you see that we have multiple projects in a solution. Okay, it's always one solution, one problem. You see, I unchecked that thing, so I have multiple solution in one project now. NAA dash March 13th. And we're going to just keep it at that. We're not going to do anything with it probably. If we do, I'm going to come back over here and write some sample stuff, but everything's already written. So I'm just going to come over here and say add existing project. And I'm going to go to OOP244, notes, notes. Did it create the notes outside of the thing? Where is my 12 March 13th? Sorry, I'm going to pause the recording. Okay, so thank you. So I'm going to add existing project. Now I can go actually to 244, to notes, and give me a second. Here you are. Okay, because I think it blocks it from there. So, anyways, so notes. Now I can go here, and I'm going to paste the project right over here because I already have it. So I'm going to go copy and paste it here. Okay, now because I have several different solutions, I'm going to right-click and say set that as startup project. So it's going to set that as startup project. When I run this, it runs that one and not the rest. So I want to create an animal. You see, DeepSeek was saying the same thing. It was amazing. So I want to create an animal. I want to have an abstraction of an animal that interests me for whatever I have, or that I have in my application. So what I do, I will say an animal is a creature with a name. I have some constructor. I created some copy constructor stuff over here that I'm going to remove. They're irrelevant to what we are doing. So in next versions, you're not going to have the copy constructor and copy assignment. Well, because we are coming from that, this is a good way to trace this and check things how they work. But what's important for us is that an animal has name. It can get constructed if I don't mention what. It's a nameless animal. You can set the name of the animal or get the name of the animal with a modifier or the query that I have over there. Are we okay with this? And as you see, the name over here is overloaded, which is polymorphism, right? I can set, I can get, and an animal can act like an animal, can move like an animal, can make a sound, and it gets destroyed when it's gone. I don't have any dynamic memory allocation or anything. There are no needs for the structure and the stuff, but they are just there so we can see when the object's getting destroyed by inserting messages in there. And that's all I'm doing. So an animal, in my view, is a creature that has a name. It can act, move, and make a sound. And how do I implement that? This is how I implement it. So, and also, I have a utils file I have to show you over there. Utils is the stuff that I'm doing in here. So I put all the things that I had over there, are all there. Too lower. This is the utils file that I had from ages, and I brought from semester to semester, and it got accumulated. So it has all the stuff that you have for string header file, so you don't need to include string header file. It has two lower cases, something, string cat, string compare, compares to screen, different types of string copies, string copy. So the good thing is that these are all members of a utils class that I can use anywhere I want. It has all the good stuff that you may not need it at all. It's just there. And one important thing that I have over here that you need to understand is what we had on the test, how to make something global. So you see in the utils.cpp, I create an instance of utils and I call it UT. Okay? So that UT at line 5 is an object of type utils that I create. And it has all those functions in it. Now I want to use that UT everywhere. I can't. It has file scope now. That thing has a file scope. It cannot be seen anywhere other than utils.cpp. So what do? I have to create a prototype for it in utils.h. So wherever utils.h is added, that UT is recognized. How do I add a prototype for a variable? That's called extern. You see that? Extern utils UT. That tells to any file that includes utils that the object UT exists. So if I want to do a string copy, I'll go ut.stringCopy. ut.this, ut. So utils does all the dirty stuff for me. It's my utility pack. It's my toolbox when I'm going plumbing. I take it with me so I can do stuff with it without thinking about it. So I can pay attention on inheritance instead of string copy. Okay? What is extern bool debug? Debug is another variable that has file scope over here and is set by default to false. So any message that I want to turn on and off, I put it before an if statement for debug. If debug, show this. So I can turn all the messages on and off by setting the default debug to on and off. I made that one global too. It was file scope, now it's global. Do we understand all this? Any questions about utils? I don't want you to think like, what the heck is that UT when I'm actually writing code over here? We know what it is, right? We're all good? Okay? All right. That's my toolbox. Now, so as you see in here, I am creating an animal, and I'm going to say, animal has a name. I am using the setter for the name to set the animal's name. Then I'm saying if debug, creating yada yada. You see that? So if debug is on, it's going to show me. And I created some copy constructor and copy assignment that you can completely ignore it. I just put this one over here if you want to test with animal when the objects are copied and stuff. You can use this, but ignore these two. We don't have any use for them. Animal name returns the name. This is an accessor that we have. It's a query that we have. Returns the animal name, both constant. So it returns something out without people being able to change them. And the animal name that is copying, it's copying it's setting the name with a value that is coming in cautiously, which means it's not going to go more than 40. So it's going to be safe. If somebody puts something that is longer, it stops at 40. And as you see, I'm not calling it strncopy because Now I have polymorphism, right? So this str copy that has 3 arguments, unlike strn copy, actually null terminates. strn copy does not null terminate. You know that from IPC 144, right? You had to do it yourself manually. With my str copy with 3 arguments, it actually null terminates, so we are fine. And the behaviors that are public to everyone, and everybody wants to know, is that how an animal acts. It act like an animal, move like an animal, sound like an animal, and when the animal is going out of scope, it's got to say removing the animal. Okay? So essentially, I created an object that I can trace its existence and see how it works. Are we good down to this point? All right. So let's try it and see how it works. So as you see, I am setting the debugging to true, and I'm saying I have an animal A called Fluffy, okay? And I say act, move, make a sound. Then I'm going to say show animal, and I'm passing the animal by value and returning it by value, although I'm not even receiving anything in here. I just wanted to demonstrate how the copy constructors and stuff are called. And then I end the main. So I walked it, and you should do this. So when you go home, you start walking through this, pressing the F10. You start the program. 3 years later, when it compiles it, okay? So debugging set to true, and I'm going to take this off, put it at left side, put the output at right side so I can see what's happening. So assignment at the moment of creation is, I'm going very slow, by the way, much slower than other semesters. Other semesters, by now, you knew what an inheritance was. Now I'm trying to sink in. Assignment at the moment of creation is? Assignment at the moment of creation is?
Initialization.
Assignment at the moment of creation is initialization, correct? My back hurts. Come a little forward. I have to. Okay. Assignment at the moment of creation is initialization, which essentially is? Assignment at the moment of creation is?
This one is Fluffy?
Yes, it's Fluffy. That's right. But assignment at the moment of creation, and I want you to listen to this. I mentioned it when I was teaching constructors, but I see you forgot. Anybody knows what is assignment at the moment of creation? That's the stating the obvious. Of course it is. But what it is? What is assignment at the moment of creation? No. It's a call to a one-argument constructor. Assignment at the moment of creation is a call to one-argument constructor. Okay? Remember that. This is important. You know how many of you made that mistake when I put it in the walkthroughs? I put assignment, and all of you called the assignment operator. Assignment operator overload is not this. This is initialization, as you mentioned it, right? That is in, who said it's initialization? You said, who said? Somewhere. So assignment at the moment of creation is initialization. And initialization means a call to one argument constructor. So this code and this code, these two are identical code. If I write it like this, and the funny thing is that I have the answer in front of you and you don't read it. Okay? So it's the same thing as this. And the same thing as these 3 lines are identical. The translation of the code of this, the compiler translates these 3 codes as the same thing. Assignment at the moment of creation is a call to one argument constructor. We clear on that? Are we good? So let's continue. Now I'm pressing F11 to go inside the function. So F11 goes inside. As you see, one argument constructor is called. before one argument constructor is called, the initialization happened. Anything you initialize in a class happens before even the constructor is called. So that's first. If you had some initialization in this class, that would have run. Okay? So first, and what does that do in front of an array? When you initialize an array,
As a 0.
0 to what?
0 to...
It is perfect. It's not 0. It nullifies the thing. But how does it do it? It literally sets everything to 0. All 41 elements of that thing will be 0. If in that one I put an A and B, element number 1 will be set to A, element number 2 will be set to B, and everything else will be 0. Remember that. And that's why when you put empty curly bracket, everything becomes 0. So when I say make sure the array is 0 at the moment of, don't write a loop and set everything to 0, just put that in front of it. Right? We're good? Are we good? Yeah. All right. You can pass it to my friend over there. Okay. So that's done. So that's going to run. And then after that, the set for name will be called. So it passes the name to the setter. It comes to the setter, receives the value, that is fluffy, using SDR copy of utils. I'm pressing still F11. Using SDR copy of utils, it copies everything, and it says, unlike strncode, this function null terminates. Null terminates, and when it comes out of this one, we will see that in here. I'm going to type this. When I type this, it means show me what is this object. You see, fluffy is in this object now. Are we good? So now it's set, and indeed, because debugging is on, it's going to say creating Fluffy the animal. And it comes out, now I have Fluffy. Now I'm going to say act. It's going to say act like animal. Then it says move like animal, sound like animal. Now I'm going to say show animal. When you call a function, in C, this is how the function is called. Remember that. When you call a function in C, this is how the function is called. You see over there, put the attribute, put the signature of the function, and the passing arguments become initialization. What is initialization at the moment of creation? What is initialization?
Pass.
Hold it. What is initialization? What is assignment at the moment of creation?
One array constructor.
One argument construct. I mentioned it 3 seconds ago. Okay? What is assignment at the moment of creation? One argument constructor. Now give it back, please. Thank you. Knowing that this is one argument constructor and the argument that is passed to it is an animal, what constructor is being called here? Which one argument constructor receives the same object when it's actually doing it? What are different types of constructor? You have a
Constructor and the deconstructor.
Yeah, but we have two different types of constructor. We have constructor.
The copying.
Thank you. This is a copy constructor because it's copying the same object. That's why passing objects by value calls a copy constructor, because it's assignment at the moment of creation, same object. Therefore, doing that will actually go to the copy constructor. As you see, again, construction happens and everything is going to say copying Fluffy the animal by setting to Fluffy. So it essentially copies it. And a copy of animal A is passed. Oh, I passed through it. OK, stop. I wanted to press F11. I press F. Which one? There you go. So I was here. That creates a stop sign. Now I'm going to press F5, and it goes right stop at that point. You see? OK. So I was at this point, and it created the fluffy thingy. Now it's going to showing fluffy. And when it wants to exit, what does it do? It's returning the x by value. So what happens when it returns the x by value? It copies it again to a nameless object to return it out. Completely useless thing to do at the moment. So another copy is getting created. You see that? Now the copying is done. As soon as it comes back in here, it gets destroyed. That's the nameless object that is destroyed. It's getting destroyed, removing Fluffy the animal, and then goes to another destructor. What is this one? Two objects are dying. Why? One was created when I passed this by value. One was created when I returned it by value. Returning by value looks like everything is good, but you're doing lots of extra stuff. Now it comes out, and it says removing Fluffy the animal, and now it comes back here. So by showing, calling the show animal, and passing by value and returning value, see how much stuff I have done. And now we get out, and now the A will die. You see that? Now please take, you see the number of things that happened over here? Please take a look at this. You see that? Now take a look. Okay? I'm going to write it again. Sorry. I'm going to write it again. See what happened? Same thing accomplished, but number of executions, memory stuff is 1/3 of what we had before. That is why we pass objects by reference, not by value. Every time you are passing something by value, either through argument list or through returning stuff, you are creating a new copy of the object. Don't. Obviously, if I wanted to write this thing properly, I wouldn't have done it like this. I would actually write over here const, because it's showing the animal. It's not supposed to do that. And in here, I would say const, because I don't want it to change. I just want it to show the animal, right? It would work the same way, but that's safer. All these things that I'm showing you is the way we program. Are we okay with this? So all the stuff that I have done over here, just review of what we have done down to this point from the beginning of the semester. How to encapsulate, how to create setters and getters, copy construction, classes with resources and stuff, what actually happens, and all the good stuff. So are we good down to this point? We're okay?
Overload.
No, it's just, this is, you're supposed to know all these things. This is halfway through the semester. Okay, so this is what we have. Okay, now, deep breath. I will put them all aside. Now that your brains are warm and nice and ready to learn, we're going to start the inheritance. So I have an animal, and I'm going to remove all those copy constructor stuff out of it. By the way, if you do something like this and run it, it picks the bright one. You see that? I have two different, that's an overload, right? I put them both. One that has animal by value, the other one has constant. When you're doing something like this, it wants to lessen the thing. So it's going to pick the right one, pick the constant one. But let me just comment this, and I'm going to say good way. This is one of the things that students always come and say, but it works. Yeah, if I turn the messages off, if I turn the debugging to off, false, you won't see anything. So you don't see what happens behind the scene. It looks like it's working. But if I turn it on, then you'll see the disaster that is happening behind the scene that you're not supposed to. Oh, what happened? Oh, so that's not horrible weight. This is horrible weight. When you do like this, you see that this happens. Okay? All right? So, yeah. Questions? Suggestions? Objections? All right. Now that we have done this, say, what's the time? 11:41. We have 40 minutes to go. If I give you 5-10 minutes break, you will be back in 5-10 minutes. You're going to go for 25 minutes. 5 minutes, 5-10 minutes. So I would say 5 minutes, so you're back by 10. Okay? And then we'll continue. All right? I'll pause the recording. Remind me to start again. I'll be asked to explain rule of 3. Rule of 3, it means if a class has information outside of its scope, the only example that you know for it is dynamic memory allocation. So essentially, rule of 3 says if you have a class and that class has some value, let's say this is some value that it has inside of it, that is fine. But then it has some value that is not inside of it, but it's outside sitting somewhere. These type of classes, they cannot copy themselves because they are only aware of their own scope. If you try to copy them, if you try to copy them, what is outside will not get copied because the compiler is not aware of that. For this, you have to have rule of 3. Number 1, you need to teach it how to copy itself, which is copy constructor, which means in a copy constructor, you should manually copy that and give it to the new class. Number 2, assignment. If this class is assigned to another class, the only thing that is assigned is what is within what is within its own scope. Therefore, that's going to get missed. Therefore, you should teach it how to get assigned to itself, to its own type, which is overloading copy assignment. And because, again, when it dies, compiler only takes the guts out, what is outside will remain as leak. Therefore, you have to have a destructor. So having copy constructor, copy assignment, and destructor implemented is apply rule of 3. When a class is referring to some information outside, is handling some information outside of its own scope. No, this is not the other class. This is, so just to, better? It's not the same class. It's information outside of the class. So the animal that you see, first of all, this is the animal that we're going to work with, okay? Protected, forget about it. Forget about protected for now. Let's remove that, not to confuse you. Okay? This class does not need rule of 3. Why? Because its name is 41 characters. It's inside the class. Right? This class needs rule of 3 because it doesn't have the name inside. It's a pointer. It's going to allocate the name, the green part over there, outside of the class. Therefore, when it copies, only the pointer is copied, not the content it's pointing to. We're okay? Please ask these type of questions even if it interrupts the session because it's important. Are we good? And look at the slides for copy construction. Okay. Okay, so now we have the class animal over here. Okay. Now we have the class animal over here. And as you see, I removed all the rule of 3 stuff. We don't need it. Okay? Now, so I just want to focus on inheritance. Now I want a cat. Cat is an animal. Okay? What does a cat have that an animal doesn't? Mythically. Anyone? Sound is different. It's not that it doesn't have sound. All animals have shape. I have shape. I'm an animal. No, that's just a say. No. That's an attribute, or yeah, it's not an attribute actually. That's a class, but no, we are not going there. Yeah, so a cat can have name too, so we don't need that. And a cat has one extra thing that animals don't have it. Seriously, you don't know? Number of lives. Cat can 9 times, right? Right? So now I want to create a cat. Right? Right? All right, are we okay? So this makes sense, right? So I need to create, and it's not a regular animal. It's another type of animal. So how do I do that? This is what happens. So essentially, this is how inheritance works. In inheritance, what you do, you have a base class, base, okay? That has stuff, public, whatever. Okay, I don't care what it has, but that's essentially your base class, the parent class, the class that, so this is what we have over there as animal. Then you want to derive this class into a cat, okay? So what you do, this is the syntax for it. So I'm going to call it class derived, okay? Then in here, you put something that you don't need to pay attention for. Public, forget about that public, let it be. Then you say base. So this essentially means derive is a base that, then you continue. You don't need to mention what is done in the base, what you have in the base. All the things you have in base will come into derive. It will be copied. All the design will be copied into derive, and then you can add stuff to it. You have a bicycle, then you create a motorcycle. So motorcycle is a bicycle, so essentially, oh. Believe me, I don't know how to spell bicycle. That's correct, right? English is 4th language. Okay, so now in here is motorcycle. So I'm saying motorcycle is a bicycle. Seriously? Motorcycle is a bicycle that has an engine. You got that? That's how you implement in C++. So the top line number 18, this is referred to as is a. And the attributes of it is has a. Motorcycle is a bicycle that has an engine. Got it? Is motorcycle an engine? No. So that's, and they are both classes that it's using. One is has a, one is a. It does not, it will not have all the capabilities of engine. It owns it. It doesn't inherit it. But in the bicycle one, it inherits it. It has everything. So that's the syntax for it. Are we okay with this? So the syntax is that. We're going to go into details in a second. Pardon me? What to be built? The engine? So do you have a motorcycle by any chance? Do you know how they ride a motorcycle? So when you want to go faster, what do you do? You do the throttle, right? You do like that, and the motorcycle, what do? You lean down to the engine and do like that so it goes faster. So it's private. Okay? It's just common sense. Object orientation is to mimic the real world into your application. If you make that public, that's just, really? Okay? In here, I could have a class, mechanic. How do you write mechanic? Is that correct? How do you write mechanic?
Without the E.
Is that like this?
Yes.
Okay, thank you. So I have a class mechanic, public. A mechanic can access the engine. So a mechanic is a class that is a friend of engine. It can touch the private parts of the engine, take the things out and put the piston in and do stuff with it. Does that make sense now? Okay. So even for a mechanic, you have the public and private, but you make the mechanic a friend of it so it can actually deal with it. Are we okay with this? Okay? All right. Oh, this is actually, I've never given this example. This is actually a beautiful example. It explains everything. Inheritance, friendship, everything. In OOP244NAA, I want to strangle some of the students because they use friend methods, friend functions, sorry. You are never, ever to use a friend function. I know you may be asked in an assignment or something, never use a friend function. A friend function is a breach of object orientation. It means you're not object-oriented anymore. When you give access to the guts of a class to a function with no supervision, that means friendship with a function. You never do that. You give ownership to a class with a friend, that's okay, if it makes sense. A mechanic must be able to fiddle with the engine. That's why it's a friend. You make friends, you make classes friends to give them ownership over another class. Total control. You never ever make a method a friend. A function a friend. If you want a function to have access to parts of a class, you create queries in the class. You call those queries inside the function. you don't make it a friend. Remember that, okay? And we haven't even got to inheritance, and we have like 15 minutes left, which is okay. So we're okay down to this point? We know what the syntax is and everything? So now I have the animal. Now I want to have the cat. So what do I say? I'm going to say cat is an animal with number of lives. Do I need to set a name for it? No. I don't need to set a name for it because it already has. So in here I'm saying act. I'm not saying move. I'm saying sound. I'm saying play. So play is something extra that it has that an animal didn't have. Act overrides the animals. Did you say shadow? Somebody said shadowing. It was you? Override of the cat, because it has the exact same signature of the animal, shadows it, overrides it. When a method of a child, I see that people are looking at me, what the? I'll explain what I mean. Anyways, so we said cat is an animal, right? So if I don't write any of these, can a cat act? The answer is yes, because cat is an animal. Can a cat move? Yes, because cat is an animal. Can a cat make a sound? Yes, because it's an animal. But it's going to act like an animal, not a cat. So you may want to change the features of the base if you need to. When I do something, when I add these things over here, so let's say I have this. If I do like this, I'm going to say cat is an animal, and it has an additional feature called play and a number of lives. Right? Which means if animal makes a sound, if cat makes a sound, it's going to sound like an animal, not a cat. But if I want to modify the features of the base, now I can do it. Anything that has identical signature to the parent class, to the base class, will override it, will shadow it. Now, if the cat acts, it's going to act like a cat, not like an animal. If the cat makes a sound, it's going to act like a cat. It's going to say meow, not whatever the animal is supposed to do, right? But if I tell the cat to move, because it's not overriding the bases, it's going to move like an animal. Got it? That's inheritance. You can override the features of the parent and improve it or make it fit the way it's supposed to work and leave the things that needs to be not modified the same. Now, in here, I have name is a query that you get the name, right? And you have set the name that is setting the name, right? Let's assume you cannot change the name of animal. Animals should be named through their constructor. When you create them, you give them a name. Let's say it's that way. If that's the case, name should not be public, right? I don't want people to change the name. I want only the class to change the name. So I'm going to take the name and put it here, right? But when I make it private, it becomes private for the cat too. Cat cannot touch it. It's like your dad has 2 cars. He has a vintage Porsche 911 that is cost $500,000, and it has a Ford Festiva that is $5,000. Okay? Which one is going to give you to drive? The Ford Festiva, right? So, but it's not going to give it to me. It's going to give it to you. He's going to give it to you. So that Ford Festiva is open to all family. it's protected by the family. But the Porsche 911 is private. Nobody drives it but the dad. You do the same thing over here. I want that name to be able to be used by cat. I want the cat to be able to use it. But I do not want anybody else to use it. I can protect it. So when you protect something, that protection comes, it means the children have access to it. Outsider don't. In Maine, you cannot set the name. But a cat can set the name. Outsiders cannot touch it. Derived classes can. That's another level of encapsulation that we didn't have before. If you make something private, no one can access it. Only the class, not even the derived classes. When you make it protected, all the descendants of the class can use it, but not outsiders. We good? All right. Yes. Mm-hmm. Oh, you have two over there. Over there, you have. We have. Oh yeah, we'll come to it. We'll come to it. We'll come to it. Construction, again, constructions are not functions. That's why I'm not talking about it. When it comes to construction, then we're going to see how the construction is controlled. Okay? So are we clear on how these things work? How the functions are called? I'm not even showing you the code yet. Okay, I'll show you the code. It's going to be simple. You'll see what it is. Okay? Nothing happens automatically in C++. The only thing that happened automatically are defaulted stuff. Okay? If you don't mention something, the default needs to be called. How do you write a default constructor? You answered already. How do you write a default constructor? What is the signature of a default constructor?
Putting default values in the arguments.
Give it to him.
Is it the name of the class?
No. That's any constructor. Equal to default? No. Okay, default constructor has another name. It's called no argument constructor. A default constructor is a constructor that doesn't accept any arguments. It means you just write the name of the class and you want to get class created with no value being initialized to it. So default constructor for animal is at line 9, and default constructor for cat is line 11. Okay? Now, in a default constructor, you can set what the default values are. For example, you want to set the cat to have 9 lives. Right? So you can put stuff in there. But if your default values you want to put in it is nothing important, you want to be the normal default things like zeros for everything and things. So if you don't want to do anything for a class and you want it to have default constructor without coding it, either you have to create the default constructor and put an empty body for it, don't write anything to it, or you can write equals to default in front of it. If you write equal to default, it means this constructor can be created with no arguments, but just set everything as default. Okay? So default constructor is a constructor with no arguments. Remember that. Anyways, what I'm saying is that now we're going to switch to the code and see what happens. So how do we access all this stuff? Construction, destruction. How does the destructor happen? Destructor happens in a reverse order. When you put 3 things at the top of each other, you put the base, then the drive, and the drive. When you destroy, you have to pick from the top one. So everything dies in reverse order. If I create a cat, obviously first an animal gets created, then the cat over it, right? And then you have an object cat that has an animal in its partly animal. When the cat dies, first the cat gets destroyed, then the animal, always in reverse order. Okay, so that's destructor. you don't need to mention it. Destructors are not set to be anything, okay? No, no, for cat, you have two constructors now, 10 and 11 and 12, and you have one destructor.
No, I mean, first one is animal, then cat created on animal.
Always, of course. Not 2 times. Each part is constructed separately. Constructing 2 times is confusing. It means 2 animals. No. And when an animal gets created, because it has 2 parts, 2 parts will get created. It's not that the constructor is called 2 parts. 2 different constructors are called for 2 different parts. Okay? So if I look at the code for an animal, we know exactly what the code is. We've talked about it before, and we know exactly what they are. Animal is an animal. It's creating all the stuff that it's supposed to. Okay, we did that before. So I have the default constructor for an animal set the name to no name. You see that? So I'm saying if you don't put anything that's no name, defaulting the animal with no name. So I do something like that. When it's 1 argument, it's like that, and so on and so forth. Okay? So we have all the stuff for the animal that is created like before. But when we create a cat, what happens? When we create a cat, this is what happens. So I'm saying when you're defaulting a cat, okay, when you do like that, set the name as Garfield, number of live lime, yada, 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 right? And I'm saying when you are creating a cat with name and number of lives, how do I need to create the animal? The name has to be passed to the animal, right? That's when it goes to what I called initialization area. You see that? So you tell to the compiler which constructor of the base class should be invoked. You don't call it manually. You tell to the compiler which one. And you can even do it for the properties. You see that over here? I'm saying when a cat is getting created, pass the name to the animal constructor and pass the number of lives to the number of lives attribute that I put. Where's sorry. To the number of lives. You see that? Okay? So I'm saying pass the number of lives to number of lives, pass the animal to the animal, and everything is done. Now, a common mistake. I want your absolute attention on this one. We have 4 minutes to go, and this is what I want to focus on. The most common mistake for programmers who are new in this is this. They want to create a constructor for a cat. They say, okay, this is a cat. I want animal to get created with the name. And this is the most common mistake. Line number 19 is not a mistake. You're setting it. But line number 18 is a mistake. What is a constructor's job?
To create
an object of a class. Attention! What is the job of a constructor? To create an object of a class, correct? Line number 18 will not set anything. It will create an animal at line 18. It will create a nameless animal. It doesn't have a name. And we'll name it the name, at line 18.5, that animal will die. Constructor is not a function. You can't call it. Constructor's job is to build an object. If you call a constructor manually, you are just temporarily building an object. So what happens here? If you do something like this, because your animal has a default constructor, and you didn't mention how to create the animal part will be defaulted to no name. Then at line 18, another animal will get created that has nothing to do with your cat. That animal will get the name, and it will die at 18.5 before line 19 is executed. And then you keep looking. I keep setting the animal to name. It goes no name. Compiler is broken. OK? You did that, right? All right. So what I'm saying is that you have to be absolutely sure to understand the space between here and here. That space is an important space. You see that blue part over there? Where you create the constructor. And you have the space between the open curly bracket when you want to start the body. That's where you are initializing everything of the class. So number of lives over here, when you are putting at line 19, what happens? The constructor gets created. The constructor, it means I have to wrap up. The constructor gets created. Everything gets defaulted. The number of lives will have garbage in it. The animal will be defaulted to no name. Then a temporary animal separate will get created and die. Then the garbage in number of lives will be overwritten by the number of lives you have. So you're going to have, so nothing is initialized. Their fist got created with garbage, and then there will be, so what you do, if you bring it up over here and you put a column, so you put a column in here, now you are telling to the compiler, hey, when you are creating the cat, use this constructor. So the compiler will call the animal when cat is getting created. Then you will say, when you are creating, you put a comma over here. I'll bring it down so we know what it is. Then you put a comma over here. And you say, when you are creating the number of lives, I want number of lives to be used to initialize it. So what happens with this code, it's not inside the body of the constructor. It is in the initialization area, right? So when the cat is getting created, before it's getting created, first the animal part of it will be created using this constructor of animal. Then the number of lives will be initialized to that, which means the number of lives will not have first garbage, then overwritten by something. It will get created with that value in it. It is absolutely essential to understand that. Anything you write inside the body of a constructor will get executed after the object is created. Anything you put inside the initialization area will happen before the object is getting created. Or the object will be created using those things. That's why I call it initialization area. It has another name. I don't know what it is. Somebody actually told me one day that it actually calls that. I named it that 20 years ago, and it just makes sense to me. That's the initialization area. That's where you initialize parts of a class. And it has nothing to do with inheritance. That initialization area can be used for any class. You don't have to initialize. You are essentially saying, I am initializing parts of the cat. One of the parts happen to be its base part. You follow? And that's the constructor getting created. So how do we call a constructor? How do we create? How the constructors are called? You have to do it. Nothing is automatic. I could call, in this one, in this cat, you see I'm calling name. instead of doing that, I could decide that when the cat, I could decide that when the cat is getting created, instead of actually naming it, I could say when default constructor of cat is called, use the one argument constructor of animal to do something. If you don't mention, it's default. You can always change it to whatever you want. That's the thing. So it's all in your hands, how to create the base. In the initialization only area, and only in the initialization area you do that. Okay? People coming through Java, because their syntax is not like that, they actually call the base. We don't want to go there. Make the mistake. Okay? C++ does it this way. Are we okay with this? Who's going to tell me that we only explained the constructors the next time you're coming in? Okay. That means really I have to pack. Okay. So the class is over for today. We went right. Who's going to do that? Somebody's going to tell me that we did the constructors only, and then we're going to continue with the rest. OK, you got to tell me? Thank you. Because we went right down to the constructors, that's the only thing that's going to be in the quiz. So the quiz that I'm going to give you will have some concepts. I'll tell you what they are. We're going to have some concepts and just a little code to be able to do the inheritance and do the constructors for it. I'll explain what it is in detail. Thank you. Thank you.
Is the curly bracket